J'entends pas.
Recording is on.
Well, good morning, everyone. I will talk about how to find a big fish in El Dorado in the Amazon basin. So, identifying future protection gaps in Amazon floodplains, a dual season forecasted distribution of a big fish with a team from the MTD. So, the giant bonnet tongue fish, also known as Arapaima or Pirarucu for red meat in a local language, is a big fish. As you can see, it's quite a monster. I included a banana for the scale so that you can realize I always need a banana for the scale. And it's a lateral migrant species, so which means it migrates between the main stem of the river and the floodplains during the high water stage. So a lateral migration. It's not coming up the stream, just on the sides. And it's a very important ecosystem because it's nutrient rich. Every fruit and vegetable matter that falls into the water make it a highly suitable place for a lot of species. So it's an important place that is poorly known. And as you can see on the left side, on the very left, it's the low water stage. We can see the river with high resolution data, and the floodplains here, when it's filled with more water, it's a much bigger surface. And the scale that's at about like 100 kilometers, I think, in width. So it's big. It's the Amazon. And the species also is big. It's big species, and therefore it is charismatic and pretty scarce because it's at the top of the food chain, and make it more vulnerable. It is also an umbrella species. The fact that it lives into the floodplains, that is a very rich and poorly documented habitat, hosting a lot of species. So if we protect these species, we protect a lot of species. That's a good reason to protect it and its habitat. The species is of high economic value because it's an umbrella species. It's because it's caught by fishermen. It's a lot of food resource in this place. Not only one, but the habitats where it dwells, the floodplains, host a lot of species too. So it's an umbrella species. So it's a high economic value also because it also protects other species that are caught by fishermen. And it's declining, both in abundance and body size because of most of the fishing pressure, and a good reason to protect it. So I'm more specialized in climate change, so let's talk about climate change. So there's a prediction of a very severe effect of climate change in the Amazon, especially in the eastern part, the lower part, where precipitation are predicted to decrease alarmingly. So we can expect some strong changes in the future in the Amazon basin. Another problem, given the climate change, they will need to shift spatially, to shift distribution to track the suitable climatic conditions. But dams and waterfall may prevent it. So we will have to take this into account too, to see whether it's possible for the species to not to migrate, but to shift. So all of good reasons to protect the species. So how do we protect it? And because we are researchers, we will have some publication pressures and how to produce some novel science with it. Let's try to find something out of it. So how to protect it? By creating no-take zones that are predicted areas where catching is forbidden, for at least for a given time period. And how to make novel science by accounting, for instance, for hydro periods producing land. That's the original point of this issue, is that we've got two water stages and with different surface involved. So it's not usual in the species distribution modeling in ecology to produce two stage of water, two periods models, but we will try to do it. We will try to account for dam and waterfalls, at least in the discussions, let's say. And we will apply the most novel methods that enable to deal with low sample sizes. I will come back to this later. And also, we want to quantify the amount of protected areas in the Amazon, especially in the floodplains that are poorly documented habitats, which has not been done yet that I know. So I will produce a dual season protection gap analysis. So quantify the amounts in surface occupied by Arapaima that is within or outside of protected areas. And then I will produce a map and try to identify the most important gaps. So it's for practice, it's for application. I will provide it to the stakeholders, and they will deal with it themselves. Will be no longer my concern at this stage. And we will try to account for both water stages and account for future climate change, because if I say that this place is interesting to make a protection area, maybe it will not in the future because of climate-induced shifts in distributions. So in the future, one very rich area might be totally empty because of climate change. So let's take this into account. So first of all, we have to predict the current distribution, make a model that enables to predict where the species could be. So here's my methods. I will use a species distribution model approach. I will use a combination of 10 algorithms, so several regression, linear or nonlinear, multiple regressions, or some machine learning also, a combination of it all. I will use what we call an ensemble of small models approach, that is to deal with small sample size. So I will identify every predictors with a statistical approach of the species presence. And if there's more than 2 variables, and there will be more, I will only make bivariate models. Well, models that include only 2 variables, so that the statistics is not too expensive in terms of degrees of liberty. It's for parsimony. So only 2 variables, and then I will average them with a weighted mean, so that I can make something very parsimonious without losing any statistical power. I will apply a sample bias correction. Well, I will not explain it any further because I'm very tired of sample bias correction. Maxime will know. Dealing with spatial autocorrelation, well, 2 little methods. I will apply a filter on the spatial data of the species data, and I will make a spatial partitioning for cross-validation for those who know this process. So that's, basically, dealing with uncertainty. So basically, what I'm saying here is technical details, but I'm trying to produce the most advanced species distribution model that have been developed recently, apply and try to stick on the gold standards of the methods. So I will need to include spatial data, species data, into the models. So this is the map of where we can find the Arapaima. All the red dots. I took it on an open access fish database, thankfully, because we had troubles to find some data at the beginning of this project. Well, at the end, eventually, we use only the available ones online. So it's like 170 points. So that's that's sufficient, but that's not a lot. So I will include them with environmental data to make correlations with it, to try to explain the conditions into which we can find the species. So climate data, I use temperature only, because we think that precipitation data is not very precise for river systems. And I will include also habitat variables, that is the water color. It lives only in the white waters. I will show you in the next slide. So I will filter only the white waters here that are some nutrient-rich waters. What are the white waters? Here we can see the junction between black waters here in Manaus and the white waters. Well, it's brown, but we call this white waters. So they are more turbid, they are more nutrient-rich. It's easier for a predator species to hide in, and they are more efficient for predations. And then the Arapaima lives rather in the white waters. There's more food and it's easier to hunt. So I will filter only these waters. And yeah, results already. So I make statistics. These are binomial models, basically. So with there's a probability of presence, but it's not exactly a probability of presence because we do not have absence data. And we identify the climate window into which we can find the species. So here, for instance, it's on the left, it's the overall mean annual temperature. So the temperature throughout the year. And we can see here that it lives in the hottest conditions we can find in the Amazon. For instance, the other variables are temperature variability within the year or within the seasons. So it likes its average variability, less or more somehow. And then we produce predicted values that we can project on a map. And here's what it gives. So we can see here, it's the Amazon basin. We can see that the model finds very well the streams, the rivers, and its tributaries. So I'm happy it seems to work well. With only temperature, the models could identify largely the rivers themselves, because at this stage, the model is not supposed to know that I'm only seeking rivers. So, well, it worked pretty well. And you can see the black dots are the data. So some points are outside of the green area. That is supposedly the highly suitable habitat. Maybe because these are different species, subspecies, or something like isolated population that are locally adapted. And maybe it's a clue for to identify new species, because Arapaima currently is considered as a species complex and not a species per se. What about the future distribution now? So I will project these data and these predicted values of the previous step on new data, novel future projections of climate. So I will use two scenarios, the most optimistic and the most pessimistic, that exist, to see the range of the possibilities, even though they are not realistic. Well, who knows? And I will use three global circulation models that are the way to calculate the future climate, different algorithm, different parameters. Well, this will produce six projections at the end for 2017. So here's the results. So on the left, you still can see the current distribution, and on the right hand, you can see the future projections. So we can see that there will be, in the most optimistic case scenario, a shift to our south, probably to track the colder temperatures. And on the worst case scenario, almost generalized decline in the suitable conditions, but more likely to be at least intermediate or suboptimal in the south and in the west. And well, basically, this is bad. Most of the current part of the Amazon will be largely suboptimal in the future, even in the optimistic scenarios. So now I will take into account the habitats and filter only the waters, the wetlands and the water areas for 2 periods. Here, the high water stage, and here the low water stage. So it's a bit small, sorry, but couldn't make any bigger zoom, otherwise it would have been fuzzy. So 2 stages and 2 eras. We can see that today, well, the suitable habitat in green is well identified, and in the south it will be only found in the western part and in the south here. Same predictions for the low water stage. I will zoom in later. So some quantities. I'll quantify the total scores, suitability scores, and it will decrease by 16-17% during the high water stage, and almost 20% during the low water stage, which gives us another good reason to protect the flooded area, because they seem to host host more climate refuges for the future than the low water stage. And now, what about the gap analysis? So I want to know how protected are the identified areas. So here it appears in blue on these maps. As you can see, there's a lot of non-protected areas in the very suitable habitats. especially around the main stem of the Amazon River, and also in the tributaries. So in the current conditions, well, the problem is mainly on the main stem. Let's look at this histogram here. So this is the distribution of my suitability scores. So let's see, on the left, let's see it's the green parts, and on the right, sorry, the green parts, the most suitable habitats. And on the left, it's the less suitable habitats, let's say the orange part here. So we can see in gray that most of these habitats remain unprotected, more than 2/3 of the surface. And in blue is the currently protected area. We can see that this will get even a bit worse in the future. The amount of unprotected area will increase by 5% nearly. And we also can see that the most current, the most suitable areas in the future will be on the southwest of the Amazon basin. I will now zoom in for let's first identify the main points where I want to see some green into non-blue area. So the suitable areas that are unprotected, and we can see that there's many. Here's the zoom in for, here's the Purus River, and here another, the Madeira River. 2 stages of water, and we can see that, well, it's well suitable in the future, one of the last suitable areas that are worth it to protect. So I will suggest later to extend the current protected area network so that it encompasses these areas, same as here. So we can see also the differences in surface during the low and high water stage. It's a lot of surface, so largely worth making an extra effort. So let's take it into account the dispersal barriers, so namely the dams and the waterfalls. So the dams, you can see here that there's one here that might be problematic, that prevents the exchange for the eastern and the central part of the Amazon. This corresponds basically to Peru. And here towards Bolivia, we can see also that there's a lot of several dam projects or current or already built that will hamper the movements. They have to take a detour, or they will just simply cannot use the available habitat in the future. So, no problem about the Purus River and the Juruá River. Thankfully, because it's in these places that I identify the most suitable areas in the future. So a big thing is at stake for these rivers in the future. And I'm almost done talking because you might be tired of my speech too. Conclusions. The species is in trouble with climate change. Well, pretty much in trouble. Good thing is we can enhance the protected area network in the future because we identified the most sensitive places. Probably it will work also for more species. Dam, we can see that they will hamper some movements in some places in 2 regions. Well, not necessarily the worst in the future, but still important. And we can see for science that accounting for hydro periods matters to quantify climate change effects, like something like 5%, but in the Amazon, it represents a very big surface. And I'm done talking. Thank you for listening. The occurrence data comes from this reference, Céline Jezekiel. The money comes from Europe. And then some special thanks to Marie-Paul. And then I'm done talking. And this was part of the Bond project. Here's a nice picture of fishermen. And thank you for your attention, and we'll be happy to answer your questions.
Merci Nicolas pour cette super présentation. Je crois qu'il y a Vincent qui veut poser une question. Tu peux y aller.
J'écoute.
Ok, ça y est, vous m'entendez là?
Oui.
Ok. Il faut poser en anglais ou en français?
Oui, voir.
En français, c'est bien.
Comme tu veux.
En français?
Comme tu te sens à l'aise.
les zones de pêche interdites s'appliquent aussi aux indigènes amérindiens?
Il y a sûrement des traitements spéciaux pour eux. De toute façon, quand c'est pour de la subsistance, c'est pas pareil, hein. Ce sera pas la même pression. Donc ça, franchement, j'en sais rien, mais je crois qu'il y a vraiment pas mal de restrictions. Il y a, enfin, de non-restrictions pour eux. Il y a aussi, dans l'analyse que j'ai inclus, là, c'est des aires protégées plus les zones protégées juste parce que ce sont des territoires indigènes. Donc c'est pas vraiment des aires protégées, mais donc ça les inclut. Donc je suppose que voilà, si l'air est protégé spécialement pour eux, ils pourront quand même exploiter la ressource dans ces zones-là, puisqu'il y aura que eux qui l'exploiteront. Mais je j'ai pas de truc précis sur ça.
D'accord.
Ça serait bien en tout cas, c'est sûr, même nécessaire. Il s'agit de sécurité alimentaire, donc ça serait trop bête, hein.
Est-ce qu'il y a d'autres questions? Ah, Sam, vas-y.
Vous m'entendez là? Ouais.
Ouais.
Ok, merci pour cette super présentation. Juste par rapport au barrage, là, tu as soulevé cette problématique de continuité pour les déplacements des big fish, là. Et donc, est-ce que tu as déjà des pistes pour comment prendre en compte ces barrages dans tes distributions, tes modèles de distribution?
Il y avait quelque chose, ouais, que j'ai pas réussi à faire tourner parce que il fait exploser tous mes ordinateurs. Il y a quelque chose voilà, qui on renseignait des barrières et il était censé simuler les mouvements aussi, depuis les zones vertes dans le présent vers les zones vertes dans le futur. Et du coup, le fait d'installer des barrières, ça empêchait spatialement ces mouvements. Non seulement j'étais pas convaincu parce que bon, c'est vrai que si en plus sur des rivières, ça devrait bien marcher, mais bon, méthodologiquement, je sais pas à quel point c'est pertinent pour en tout cas pour mon application sur mes modèles là, sur mes valeurs prédites. Mais bon, je sais pas, je trouve que c'est aussi efficace de voir juste la carte là. On voit, c'est sur la rivière, donc ça passera pas de l'est en ouest. Si, je veux dire, ça marcherait aussi bien si je le mettais dans Paint et que je gommais, si tu vois ce que je veux dire. En gros, c'est ça que ça ferait, quoi. Puisque c'est linéaire sur des rivières, c'est facile de conclure sur leur effet. J'ai moins à quantifier là. Je considère aussi que mon espèce a une dispersion infinie. Je mets pas de restriction de dispersion. C'est sur la base de qu'elle peut un peu se déplacer toute l'année sans trop de restrictions, sans barrière physique à part les barrages. Donc, moi, je dis que d'un point de vue biologique, la lecture de ce truc-là, moi, ça me suffit, hein. Je sais pas, donc voilà. Mais sinon, ouais, voilà, la méthode standard, c'était de faire, de dépondérer, je dirais même d'annuler complètement les scores de suitability au-delà des barrières dans les zones, voilà, en tenant compte de l'avant et de l'après.
D'accord. Ok, parce que tu penses qu'il y a certains endroits où ils ont suffisamment d'espace vital pour pouvoir un peu réussir leur cycle de vie sans avoir à se déplacer en fait sur tout le long de l'Amazone.
Ouais, oui, il restera des endroits quand même, ouais. Alors, l'idée c'est qu'aussi ils vont pas se déplacer activement pour suivre le changement climatique. Ce sera vraiment, ils se dispersent dans toutes les directions au hasard, hein, comme toutes les bestioles. Et ensuite, il y aura plus de survie dans les endroits qui resteront un peu favorables. Il y aura moins de survie dans les endroits qui le seront pas. Et c'est plutôt les populations locales qui sont déjà dans les zones favorables qui vont se développer et prendre le dessus au final, quand les autres vont tout simplement décliner, quoi. Il y aura aussi des déplacements. Il y en a toujours, hein, il y a des flux de population. Mais ouais, je suppose qu'en tout cas, il y aura surtout des déplacements entre l'Amazone, là, le main stem, là, la branche principale, et puis les deux autres. Donc, pour les bestioles qui sont en fait, qui sont du mauvais côté des barrages, c'est eux qui sont un peu, qui vont se retrouver isolés. Par exemple, là, les points du sud, là, en Bolivie, ils vont devoir remonter à un moment vers le nord. Et donc là, il y a des tributaries, j'ai les mots en anglais avant les mots en français, des affluents Des affluents, donc ils vont pouvoir remonter. Donc ceux-là, il n'y aura pas de souci, mais il n'y aura pas d'échange entre les principales grandes populations, c'est-à-dire celles du sud, celles du centre, celles du nord de Colombie. Voilà. Donc ça pourra poser problème parce que ça fera tout ça de flux génétique en moins. Bon, alors après, il y a déjà des cascades, donc ça veut dire que ça a toujours été là, donc il y a déjà des populations isolées, surtout au niveau de la Bolivie. C'est aussi ça. Voilà. Donc, en fait, ce qui est nouveau, c'est surtout au niveau du Pérou, là, le point là, au nord. Celui-là, il va empêcher les mouvements entre la grande zone humide du Pérou là et le reste. Mais ça représente, j'ai l'impression, une minorité. Disons, en tant que écologue qui essaie juste de sauver les miettes, je trouve que ça aurait pu être pire. Voilà, donc, voilà.
Mais tu sais pas, enfin, tu n'as peut-être pas connaissance de ces barrages. Est-ce qu'il y a des passes à poissons, des choses qui sont faites justement qui sont aménagées pour le passage des poissons?
S'il y en a, ils seront que dans un seul sens de toute façon. Donc ce sera pas vraiment des échanges génétiques, ce sera des sources puits. Ce sera comme une métapopulation presque. Donc déjà ça sera limité de toute façon pour le côté qui est en amont. Ils n'auront pas d'apport génétique, ceux qui sont vers le haut. Par exemple, ceux de la Bolivie, là, c'est eux qui seront le plus exposés à l'isolement. Après, la région est grande, donc je suppose qu'il y aura suffisamment de diversité génétique pour que la région soit autonome. De toute façon, avec les cascades, elle l'est probablement. Je ne sais pas s'il y a des petits fleuves sur les côtés qui permettent le passage non plus. Ou alors aussi lors de crues, au niveau des affluents, peut-être qu'ils peuvent passer aussi, ça fait beaucoup d'espace de libérer. Il faudrait regarder en détail avec un zoom, je l'ai pas fait parce que l'échelle est beaucoup trop grosse là.
Ouais, bien
Faudrait
sûr.
le faire beaucoup trop bien, ouais.
Ok,
Ça
merci.
serait intéressant. Ouais. Mais je suis limité sur la connaissance vraiment appliquée de l'effet des barrages. Certains de ces barrages d'ailleurs sont des projets, ils sont pas encore faits. Bon,
D'accord.
on n'a sûrement pas les moyens de les faire arrêter.
Bon, rien n'empêchera de toute façon aussi de faire une étude de connectivité un peu plus poussée plus tard
Oui.
aussi. C'est vrai que ça pourrait être intéressant de quantifier ça un peu plus rigoureusement, mais on verra ce que
Oui.
disent les reviewers.
Oui, on verra ça, ouais. On va bientôt le soumettre. Dès que Sandra m'envoie son draft. Et bah oui, donc on va soumettre à un journal de sciences appliquées, on verra bien ce que ça donne. Ouais, pour l'instant, c'est vraiment juste une analyse. Enfin, il n'y a pas d'analyse en fait. Je mets la carte et je discute des résultats, c'est tout. Mais bon, vu que c'est de la rivière, c'est franchement ça va tout droit, quoi. C'est assez facile à interpréter, à part ces histoires de petite échelle. Par exemple, ce triangle là en plein milieu, là, je sais pas si c'est un barrage qui est sur le Juruá ou si c'est sur le Madeira. Non, Madeira, oui, c'est ça. Faudrait regarder en détail. J'ai pas zoomé, mais je m'y perds. À chaque fois, j'ai le vertige quand je fais des zooms sur l'Amazon. C'est trop gros.
Bon, bah merci Nico. En tout cas, s'il n'y a pas d'autres questions, on va s'arrêter là.
Fort bien.
Et puis, bah, bon après-midi tout le monde.
Yep. Oui, merci à tous. Merci Maxime.
Merci Nico.
Merci Nico.
Yeah. Welcome. À bientôt.
Merci.